Show that the number of binary operations possible on the set 1, 2, having 1 as the identity element and 2 as the inverse of 2 is exactly 1. A binary operation on set A is a function from A cross A to A. Here we are given the set 1, 2, only 2 elements. This is the set A given to us. Now, since we want to define a binary operation, we have to first have A cross A, the Cartesian product of A. Set of ordered pairs 1, 1, 1, 2, 2, 1, 2, 2. Now, a binary operation will be a function from A cross A to A. We're going to define the various functions. The domain has these 4 elements here, these 4 ordered pairs here. Now, altogether, how many possible binary operations are there? Let's see. For star to be a function, every element of the domain A cross A should have a unique image. That means the first one, 1, 1, should have one unique image out of these two. That will be called 1 star 1. So 1 star 1 can be either this one or this two. If you look at the binary operation table, 1 star 1, here we may write either 1 or 2. Two ways we can fill this place, either 1 or 2. So can be selected in two ways. Same with 1 star 2. 1 star 2 we can also be selected in two ways. Same with 2 star 1 can be selected in two ways. 2 star 2 also can be selected in two ways. Now, all these four places can be filled in two ways, into two ways, into two ways, into two ways. All these images can simultaneously be selected in 16 ways. So there will be 16 possible binary operations, out of which one may look like this by choosing one in every place. Here you had two options, either 1 or 2. I chose 1. Here also you had two options, 1 or 2. I chose 1. So this is one possible binary operation. Another may look like this. Just one difference I did. Here the element is 2. Last one. Another binary operation may look like this. All of them are 2 except this one. Like that, many more. How many more? We already discussed. There are 16 possible binary operations. Now, our question is to check how many of these binary operations will have these conditions given to us, having 1 as the identity element. By the way, what is an identity element? The definition of identity element is the element E will be called identity element if A star is equal to A and E star equal to A for every A of the set given to us. That means 1 star 1 equal to 1. It should be 1 star E should be equal to 1 in place of E. We want the E to be 1, identity element to be 1. So 1 star 1 should be 1. 2 star 1 should be 2. These elements I am plotting here also. 1 star 1, 1. And now 2 star 1 should be 2. 2 star 1 should be plotted here, 2. And 1 star 2, 1 star 2, that should also be 2 here. That is what the definition of the identity element says. A star E should be A itself. A star E should be A itself. For E to be 1, 2 star 1 should be 2 itself. Also the reverse. E star A should be 1. And if you want the identity element to be 1, so 1 star 2 should also be 2. A, the same. So then this 1 will be the identity element. So we have maintained the first condition. These elements 1, 2 and 2 should have been filled in these places. Now one more condition is given to us. 2 should be the inverse of 2. To have 2 as the inverse of 2, first of all we should know what is inverse element. If A star B is equal to E, the identity element, then B is called the inverse of A. And the commutativity property should be true with them also. B star A should also be equal to E. And we should notice, we have already decided E as 1. That means, to find the inverse element of 2, we should have 2 star something should be equal to 1. And the question says inverse of 2 should be 2 itself, which means A and B should be 2 and 2. 2 star 2 should be 1. 2 star 2 equal to 1 means this 1 is the E and this 2 is the inverse of this 2. So 2 is the inverse of 2. To have 2 is the inverse of 2. To have 2 as the inverse of 2, we should write 2 star 2 is equal to 1. Let us fill that also. 2 star 2. Here the question says fill 1. Okay. So we have filled all the 4 places. All 4 places had some or other specification. So we kept on choosing the elements according to the specifications given to us. First 3 went by this condition. The last one went by this condition. So we filled all the 4 places in only one way. This is the only binary operation that will satisfy all the given conditions. There may be 16 binary operations, but this is the only one satisfying all the conditions. Hence, there is exactly one binary operation that will have 1 as the identity element and 2 is the inverse of 2. None of these binary operations will satisfy both of these conditions. So exactly one binary operation is there.